Good afternoon, good morning, or good evening. Welcome to today's webinar, OData External Data Integration Strategies for SaaS, hosted by Progress. My name is Cindy Romig, and I'll be your host for today's event. Before we begin, just a few housekeeping items about the Citrix interface. When you join the webinar, by default, the audio bridge connected your device to the Voice over IP option. And if you prefer to use your phone, just select the telephone option and an automated operator will walk you through connecting to the bridge. And we will hold question and answer after the presentation. And to submit questions, just enter them anytime in the question window to the right of your control panel screen. If we do run out of time and your question isn't answered, we will certainly reach out to you afterwards. Of course, if you experience any technical issues or need assistance, please enter a message and I'll respond to you as soon as I can. We are pleased to have several distinguished speakers join us today. Sumit Sarkar, Chief Data Evangelist with Progress Data Direct, is here today. Michael Pizzo, Principal Software Architect with Microsoft, is also here today. Roderick Peace, Director of Product Management at Oracle, is also joining us. Sumit Sarkar is Chief Data Evangelist for Data Direct and an industry expert on open data standards connectivity with cloud data. Sumit has been working in the data connectivity field for over 10 years, and his interests include business intelligence and data integration for SaaS applications, with a focus on standards such as ODBC, JDBC, ADO.NET, and OData. He has presented related sessions at both Dreamforce and Oracle OpenWorld. Michael Pizzo has worked over 25 years in the design and delivery of data access solutions and APIs with Microsoft. Michael was a key driver in the design and standardization of ODBC and a key designer of OLEDB, ADO.NET. Michael is currently a member and editor of the Oasis OData Technical Committee. Roderick is a seasoned technology professional with more than 15 years in advertising, data-driven marketing, and interactive development. Roderick headed up the Oracle Consulting Architects team prior to joining product management, where he currently leads Service Cloud's Accelerators and other open source initiatives. So now it is my pleasure to introduce Sumit to kick things off.
All right, we'll kick off with the agenda for today. So Mike is going to kick us off with the overview of the OData Oasis standard, get into some technical details and give you an idea for some of the trends around adoption in the ecosystem. Then I'm going to dig into some of the specifics around OData adoption for software as a service vendors, and we'll talk about external data strategies as well as OData production. And then we're really excited to clean up with Roderick, and he's going to talk about a behind-the-scenes look at what Oracle Service Cloud is doing today with building OData Accelerators. I'm really excited to bring this to you before it's even released. I think it's going to be available. I'll let Roderick talk about it, but basically we're on the front end of all this stuff, so I'm glad you guys could join to hear the latest in OData. And let me turn this over to Mike. And Mike, I'm going to give you a keyboard and mouse, and you should have it.
Great. Thank you, Sumit. Before we dive into how SaaS services are using OData for data integration, I wanted to pop up just a little bit and provide a bit of background into what OData is, where it came from, and what people are doing with it. To understand OData, it's useful to understand some of the trends that we were seeing in the industry 5 or 6 years ago. At the time, we were seeing a real move from silos of data very closed, to really open data, and we saw that with the government. Obama made his open data mandate, requiring that all government data be open, and that was a trend throughout other countries as well. And that was a trend we saw in science, in enterprise, and really across the industry. At the same time, there was a real move from computing on-premises to the cloud, to where data was moving to the cloud, applications and services were moving into a cloud. And as part of that, we saw a proliferation of APIs being built on the cloud. So rather than the internet just being static HTML pages, there was a move to make a programmable web where services exposed APIs. And those APIs made the data available not just to browsers, but to a variety of different devices that were able to do interesting things with the information underlying those HTML pages to really customize their interaction with that data. At the same time, we saw a move from traditional SOAP operational APIs into more resource-oriented APIs. And there was an emergence of a programming pattern called REST, which basically defines things on the web as resources and then defines different operations you can do against those resources. You can create them, you can update them, you can delete them, you can fetch them. And so we saw this trend towards the web, towards programming on the web, and we saw the emergence of sites such as the programmable web, which was starting to enumerate all of the thousands of different APIs that were being exposed on the web. And most of them were following RESTful programming patterns. They were using a lot of other new technologies and patterns and conventions, but there was absolutely no interoperability, because even if a service was implementing RESTful programming patterns, you couldn't program against it unless you knew the resources that that service exposed and the URLs to address those particular resources. If those resources represented collections, quite often you didn't want to get back the entire collection. If it was a large collection, you wanted to filter your results or you wanted to sort your results. And if there were still too many results, you wanted to return those results over multiple different requests rather than all in one giant request. And so each of these APIs were coming up with their own conventions and designs and patterns for how you did those different operations against that service to make that service really usable. So although there were all of these services that were following patterns like REST, there was no way to write a single application that could communicate with more than one of those at a time. You had to write each application, each tool, each consumption specific to the service that you were talking to. So given that background, what is OData? Well, OData is really looking across all of those services and identifying those common requirements and the common patterns and identifying some best practices and then encoding those best practices into a common set of conventions such that you could have interoperability, so that each of the services that were implementing those could both be a well-defined REST service and could be consumed by a generic client that didn't know a priori what the resources it was talking to might be, that didn't know a priori some custom conventions for how to do things like filtering and sorting and so forth. So what is OData? What are the conventions that it defines? Well, first off, as I said, in order to work with a service, you have to understand the resources that are exposed by that service. And so OData defines a common, uniform, and consumer-oriented way to describe the resources exposed by a service. And the way OData chooses to describe those resources is in a very consumer-oriented conceptual model that, rather than something like the relational model of a database that describes the world as relational tables with constraints and foreign key constraints, it describes things the way that we see things in the real world as entities or objects and relationships of those objects to other objects. Once those resources are defined, then the REST principles can be applied to those resources to define addressability, operations like retrieving with a GET, creating with a POST, updating with a PUT or patch, and deleting with a delete operation. The other thing we found is that although REST is great for those common so-called CRUD operation, create, read, update, and delete operations, there were other operations that were more complex, and it was useful to describe those as operations or actions as opposed to interoperating with those resources through those CRUD operations. And so OData defines custom actions that you can take on those resources. Beyond that, there are uniform URL conventions for doing common things that you might want to do against a resource or a service, like navigating through the different resources of that service, filtering or sorting, paging across the collections returned by the service, and then custom functions for encapsulating logic that defines a set of resources that you might want to return. Once you have that conventions for the protocol itself, you need to describe how the results are represented. And again, there was no uniformity 5 or 6 years ago across how results were returned. XML was probably the most prominent way to return results at the time, and there was something called Atom, which was built on top of XML and used for describing payloads. But even that wasn't sufficient because Atom described within a payload what was an ID, where you could go get a description of the type and so forth, but it didn't actually describe how properties of an object were represented. And so OData in its early days used an Atom XML-based format, and then it also defined a JSON format. Well, over the past few years, XML, partially because of its verbosity, has become less popular, while JSON has greatly gained popularity. And so OData's current preferred format is actually a very simple JSON format that we've defined an annotation mechanism that allows you to take JSON that looks very much like a custom handcrafted JSON format to describe data, and then it annotates it with information like the ID of the resource that you're working with, its link, the links to get to other resources, links for additional pages, and so forth. OData defines a common annotation mechanism both for the data payload as well as for metadata that allows you to basically extend OData and to share those extensions in shared annotation terms that are grouped together in what we call vocabularies. Finally, OData was moved to OASIS and became an OASIS standard in February of 2014. All right, so what were the defined conventions then that OData defines? Just to go one level deeper. As I said, OData defines a set of requests, a common request that you know you can use against any OData service that allows you to describe the metadata of that service. So it describes the service document that lists the different resources and the collections that are available at a top level, and the metadata that describes the resources that you can get back. As we said, there are CRUD operations for retrieving a resource, querying, inserting, updating, and deleting a resource, and the ability to have custom functions and actions. Additionally, OData defines requests for batching operations, so you can send multiple requests together in a single request and get back multiple responses in a single response. And then OData defines something called delta requests, which is pretty interesting. It's the ability to request just changes in data since a particular point in time. So if you have a very large set of data, you may need to retrieve that data only once, and then after that time, you can just find out the few records that may have changed since that initial request. OData defines URL conventions for things like navigating relationships across the resources, and query conventions for, as we said before, filtering, sorting, top and skip, expand operations that allow you to specify the depth of a graph you want to retrieve in a single request, projection for filtering out some of the columns that you may want to select, and aggregation for pushing aggregation functionality to the service and bringing back just aggregated results. And finally, as I said, the preferred format for OData is the JSON format. And the JSON format is extended to support things like description of the payload, what a particular JSON document represents, the count of a collection, type information, IDs, how navigation, edit, and media links are represented within that JSON payload, and then custom payload annotations, as well as for delta responses, how you represent things like a deleted resource or an added or deleted link between resources. So who uses OData and why and where? Well, really we see OData used across all types of data, from enterprise to government, from consumer to healthcare, and then a lot of custom data solutions that don't necessarily hit the radar. People are using OData because it provides, first and foremost, a very simple model for consuming the data. Because it's HTTP-based, any client can access the data from any platform or device that has an HTTP stack, and you don't have to install custom drivers or libraries in order to use the OData API. So to contrast that for a second with ODBC, and as Cindy said in the introduction, I have a very close affinity to ODBC. I spent a lot of my life on that API. In order for a client to use ODBC, it has to have the particular ODBC driver for the backend that it's talking to. And that's not true with OData, because OData is a protocol, so as long as the service that you're talking to supports that protocol, you can call that with no additional client-side libraries. And that's very important for a lot of the data consumption scenarios we're seeing in the industry today, particularly with the explosion of SaaS data sources, where there are so many and the set of interesting SaaS sources evolves so quickly. Trying to write and install drivers for each of those SaaS services on all of the clients that might want to access that data becomes untenable. As I said before, OData exposes a very consumer-oriented conceptual data model, which makes it very easy to come up to a service that you haven't seen before, understand the resources that are available in that service, and start coding against that service. The fact that the OData conventions are defined as a standard and standardized provides interoperability that creates an ecosystem of tools and applications and libraries and services, all of which follow the same conventions and therefore get interoperability. And then a lot of people use OData even without interested in the consumption and the reach as well as interoperability, simply because it's a rich, mature specification that encapsulates a lot of the best practices for building REST services. They don't have to go out and define their own conventions for doing sorting or filtering or paging or deltas or any of these other advanced concepts. So this slide is by no means meant to be exhaustive, but simply representational of some of the different breadth of services and applications that are using OData today. And you see everything, all sorts of different uses on this slide, everything from not just the SaaS services that we're talking about today, but you see enterprises like SAP, IBM, Oracle, and Microsoft that are using OData. You see data integrators like Progress, CData, and Informatica that are using OData to make their data available to a wide number of applications. You see data analytic and machine learning applications like Excel and Tableau for the data analytics, Azure Machine Learning for doing machine learning over OData data. The Office 360 API is an OData API, so you can talk to your Exchange services, your OneNote, and so forth, all using OData. You see OData becoming popular in government data. You have CCAN as a data platform that has an OData plugin. Socrata, which exposes their government data using OData. And you have various different government agencies like the U.S. Department of Labor, City of Edmonton. In New South Wales, they have a biodiversity project which exposes over 7 million species sightings as an OData service, and they're getting a great deal of benefit out of doing that, both in programmability and the ability to import that data directly into Excel and do charting and analysis of that data. So you see it really kind of everywhere. On the development side, you see development platforms like Apache Lingo, which provides the ability to implement services in Java and to consume OData in Java and JavaScript clients, and Visual Studio.net for writing OData services in .NET and consuming OData from .NET clients. Similarly, you see PHP, Drupal, and all of these other platforms that are adding OData support. You also see other standards efforts like the Distributed Management Task Force Redfish specification that has aligned with OData for a RESTful interface for managing systems within a data center. And then there's many more that we don't that we don't know about, like a lot of these custom data solutions that I was mentioning before. Last year, I was giving a talk at the Intel Developers Conference, and I did a search on Intel OData, and I found out that Intel's product list is an OData service, which I hadn't even known before. So again, OData has a wide breadth of implementation that goes well beyond just a single client service scenario. So I wanted to conclude by talking a little bit about what's going on with OData today. OData wasn't just a specification that was published and then kind of walked away from, but since it's been published in February of 2014, there's been work going on in the industry as well as in the OASIS Technical Committee to continue moving OData forward. So one of the reasons OASIS was chosen as a standards group for OData is because it's a direct contributor to ISO. And OASIS has submitted the OData specification to ISO. The ballot for that closes at the end of January, so by February, OData could be an international standard. There's ongoing work in OData. As I mentioned, OData has a way to describe the resources that the service exposes. Currently, that's an XML-based language for describing the resources, and we're working on a JSON-based metadata format for describing the resources based on JSON schema. There are new extensions going on, the aggregation extension I mentioned earlier, and we're looking at temporal extensions because that's becoming more interesting for things like time slicing data. And finally, there's a set of simplified patterns and practices for using OData, particularly against completely unstructured document stores, and those are defined as part of what we're calling OData 4.01. So again, this is intended to be sort of a quick overview to provide some background into what OData is, how it came about, and some of the functionality that it provides. And with that, I'll hand the pen back to Sumit to talk about how SaaS services are using OData to suit some of their scenarios.
Great. Thank you, Mike. It was a fantastic overview. And I think it segues right into this, what we're seeing with the software as a service vendors and OData adoption. So you have that broad adoption, but when we look at software as a service vendors, we're seeing adoption for different reasons. And when we dig into it, I think this wave of adoption is really driven by those observed trends that Mike mentioned around interoperability and APIs that support both on-premise and cloud sources of data. And here's just a list of some of the producers, software as a service producers that either produce the OData natively or through some form of partnership. So you see a wide adoption here on the producer side. So these guys have REST interfaces to their applications through OData. And then when we look at the other side of it, which are the OData consumers, and that's where we get into the external data strategy part of the webinar. We're really seeing wide adoption on external data strategies for SaaS vendors, and we'll look at the history. If we go back to the left side of this screen, you can see in we'll call it the on-premise world, where ODBC was king and Mike was working on ODBC. You see there's a lot of technologies that had external data strategies. Oracle has gateways. Microsoft SQL Server has what we call link server. Postgres has foreign data wrappers, and IBM Sybase, they all have similar concepts. And these are external data strategies where it's based on some standard for interoperability. And that standard was ODBC in the on-premise world for most part. And these allowed applications like an Oracle database application. It could query data in SQL Server in real time through these external data strategies. And it was a common code base, and it can connect to anything. And when we move to the cloud, we look at some of the adoption there with Salesforce Connect is the first to release about, I think, in November of 2014. And Progress Role-Based has external data strategy and Service Cloud as well, which Roderick is going to talk about in a moment, what they're doing with the external data strategies. And one thing, when we compare ODBC and OData, Mike and I were talking, and while sometimes I do refer to OData as being ODBC for the web or JDBC for the web, one distinction is that SaaS vendors might think of OData as being the API of a service rather than where ODBC is an API to a database. But at the end of the day, they're both interoperable standards to data. And when we look at what that really means for a SaaS vendor building an external data strategy, you'll hear this from Roderick also, but we can, with this OData as a consumer, when we look at Oracle Service Cloud as an example, if it can consume OData and all these different systems have capabilities to produce it, all of a sudden your Oracle or your cloud application is moving to become more of a system of engagement as well as a system of record. So when we look at standards-based connectivity, having this external data strategy really elevates the value of your data if you're producing OData, because then it goes out into the stacks. Let's say it gets into the Oracle financials or under or IBM reporting. All of a sudden, your data is elevated in the enterprise. And then when you're consuming it, obviously it elevates the value of your application as a consumer because you become that front end to all these different systems. And this arrow shows where the Oracle Service Cloud agents might be interfacing with any of these systems, and OData provides that interoperable external data standard. And when we think about what is driving some of the OData adoption as external data strategies, it's really a lot around citizen developers. And there's a definition from the Gartner IT glossary. Citizen developer is a user who creates new business applications and for consumption by others using development and runtime environments. So this is really, what that really means is that we're seeing with software as a service vendors, we're seeing trends for more citizen integration, citizen developers. We're seeing more trends around line of business users needing to control integration and data access patterns. And so in order to support that as a software as a service vendor, you really need to have a standard, and that's where OData is coming in, because with that standard, that user can drag and drop and have a real self-service interface to external data, and that's all really driven by having a standard, because that end user doesn't really care or know what that data is they're accessing. They just know I need an OData URL, and I'm off and running. So that's really the trend we're seeing. And with Salesforce Connect, since it was the first one, we have more information around what data is being accessed with that particular cloud application. But in the sales and service CRMs, we're seeing that in the cloud, they want to reach out to different systems. A lot of marketing applications, even these might be in the cloud, things like Eloqua, Marketo, HubSpot. Customer engagement, things like Oracle Service Cloud or access from Salesforce. Other systems as well that may be in that space. Lots and lots of ERP activity, and we see things from Oracle, Siebel, PeopleSoft, JD Edwards, all sorts of SAP is a popular one. All those sometimes are systems of records or remain behind the firewall, so very valuable to access over OData in the cloud applications. Then obviously data warehouses and big data. On the same vein, there's just vast amounts of data. It just doesn't make sense to copy it all into the cloud. So these external data strategies are letting SaaS vendors just access the data they need, but have access to all of it. So if you have terabytes of data, you might just need a little bit of it. You can access it in real time over these external data strategies built on OData. And I'll show you a quick demo just to see what it looks like with the Salesforce ecosystem, in particular with Salesforce Connect. And I did this a similar demo at Dreamforce last year, and a lot of citizen integrators and developers really wanted to learn more on OData, and I think that it's definitely expanding in terms of adoption, especially with the Salesforce Connect announcements and developments. So let me show you a demo of what that looks like. And for the sake of time, I'm going to show you more about what the interfaces look like. So this is a Salesforce developer account. It's a CRM application. And if I look at this external data sources, which are built into the platform with the Salesforce Connect piece, you can see here that the feature is called Lightning Connect here, but there's different OData URLs. And these are endpoints to different data sources. Some of Eloqua is running in the cloud, and I have a data warehouse here. This is a Progress data warehouse internally. And these are all using the Data Direct Cloud service that Mike had mentioned in the ecosystem as one of the integration producers. And if I click on this data source or for this Data Direct Cloud data connection to Progress, our data warehouse, you can see there's a couple of objects exposed. And these are all, let me show you the OData. So this is the OData endpoint, and we are authenticating. So as a business user, this is really all the information I would put in Salesforce. And now I can look at my metadata on the invoices. And what Salesforce has done is they're treating this object as a external data source, and it actually resides in the data warehouse. And so these objects are mapped from OData into native Salesforce data types. So again, you can see the power that whether it's a enterprise data warehouse behind our firewall or a marketing cloud, it doesn't matter so much. So as a citizen developer, if we treat this stuff as native in Salesforce, anything I do from Salesforce, I can get access to. So those invoices, let's say I just want to do something simple like create a new tab or something like that. I can just go to create and go to my tab, create a new one, And you can see here that since it's integrated in the platform, here's my order, invoice lines and invoices. So, or invoice lines is what's being pulled. So that's what we have built into the Salesforce Connect experience. And this is all powered by OData. I'm not going to run into this further, but Roderick will also show some more capabilities. But what I do want to show is not necessarily the Salesforce, but I do want to show where the OData is being produced from, and that's in the Data Direct Cloud service, which is a Progress service. So I'm going to log in and just give you an idea. So the reason that this use case and demo is so powerful is that the cloud application, the most common use case is to get through a firewall and have it be a self-service experience. And so Data Direct Cloud is a service that can do that in the most direct way. It connects directly to the data and produces OData from that data model from the data source. So you can see there's a whole lot of different sources that we can support. There's Salesforce and Oracle, and we produce OData from any of these types of databases or core databases to other applications. And when we look at the data warehouse for Progress that I showed you earlier that was accessed from Salesforce, you can just see that it's just a matter of providing some connection information to that database, so a server name, port number, and a database. And there's an on-premise connector piece that gives you the connector ID, and that's what gets you through the firewall piece through over HTTPS and firewall-friendly protocols. And I'll just click on OData, and you can kind of give an idea of what that looks like. This is where the schema gets mapped. This is a live data warehouse. It's not live, but it's a development environment. So hopefully the Progress IT guys don't get mad at me. Hopefully they're not on the webinar. Let's see if it's going to pull up here. And since it is a dev environment, it may not be as fast and speedy as our production environments, but you know how live demos go. So I'll let that spin for another second or two. I'm not sure what it's waiting for, but that data, when it's one thing to consider in Salesforce is that when you're actually querying that data and looking at the actual data itself, it actually gets wiped out from memory when you close the page. So it's always real time with the Salesforce Connect, and the same thing with what Roderick's going to show you in a moment. So let me get back to the webinar here, and let me now turn it over to Roderick to dive into what he's really working on today with the latest external data strategy with Oracle Service Cloud. So Roderick, I'm going to make you give you keyboard and mouse. So the show's yours.
I think the amazing part of what Sumit just shown was the breadth of the community, and I guess when you look at standards, that really is the proof that the standard has value. Is that network effect as the community and the number of providers expand, the value to everyone increases, and that certainly is what we're seeing. So I want to do a very brief overview of what Service Cloud is, just so that the examples I show aren't completely out in space and have nothing tied to it. If you look at Service Cloud, it's a contact center application that allows a single customer service agent to take people's requests from whatever medium they're comfortable in. And so if you think about a person working inside a corporation that's trying to answer questions about a potential problem with a product or maybe a problem with a service, or maybe Sumit's development database back there that won't spin up fast enough for the demo, where would you create that request, or how would you get in touch with the person? And that's what the Service Cloud product automates, is bringing all those different possible engagement points into one system of record. So regardless of whether you started out on a mobile device doing searches against knowledge base or inside a mobile app, or whether you went to a web portal and opened a ticket saying, hey, I have problems with this connection, or whether you jump straight on live chat, the contact center agent down inside, working within the brand, has the same contextual experience. They work in the same piece of software, and they know about the whole contact history that person had. So whether they started on a chat and then went to email support and eventually called in, it would all be centralized into one database and one interface for the agent. That just gives you a little bit of background on what the product does. So I run the Accelerators and open source projects for Oracle Service Cloud. And so I guess the first question I would ask is, what's an accelerator? An accelerator, from my perspective, is an open-sourced reference integration between major platforms. So you saw the Salesforce integration that Sumit was presenting. My projects would be the reverse of that. How do we bring high-value data out of a system like SAP or Salesforce or one of the Oracle products into the Service Cloud product in a very efficient way and drive down the adoption time or the discovery time for an individual company that wants to adopt the standard or wants to show both those systems integrated? Next question I'd ask is, why would we build one on OData? And I think the key thing here is Oracle could productize our integrations between a whole bunch of different systems. We could make a direct connector, a direct ODBC connector between Salesforce and Service Cloud. Or we could make a direct connection or a direct accelerator between SAP and Siebel and Service Cloud. But when you look at that is an infinitely expanding list when people keep building new cool resources, new cool services that could be integrated into the Service Cloud infrastructure. So we have a preference for building things on standards, and OData is the one we chose. The other reason is that the reason people have customized ERP solutions is because the ERP solution serves some core value in the company. The example I like to give is around a service-related system we support today. If you were to call into this particular customer and say, hey, I have a problem with my system, they wouldn't say, well, thank you, President Obama, we'd love to give you awesome service. They'd say, please flip over your laptop and give us the service tag off the bottom of it. And that's a completely different way of handling service than any other customer I've ever seen. But it works because it's a core differentiator. They route you to a person that knows that laptop perfectly, intimately, and can give you high-quality service. So being able to surface that custom business value inside our contact center application produces huge value and makes our application sticky. And that's why we don't productize integrations to systems that are so customizable. And if you look at the plethora of services out there in the SaaS marketplace, the same thing applies. So why do SaaS vendors want to have external design patterns? I pulled some example sites off of our cloud to give you an idea of like the different models you see. This graph shows a bunch of very big databases. This is core MySQL databases underneath our cloud application. And if you notice, they're customers that have almost no transactional or auditing data in their system, and all their data is operational or primary data. And that's data that supports the purpose of the contact center agent, getting your information quickly, solving your problem quickly, handling transactions quickly. But then you have other customers that have almost 60% of their database is this secondary or audit data. And what that really means is that their database is full of stuff that doesn't actually drive down the handle time or improve the experience in the contact center. It's just there to surface for some other purpose, like reporting or giving the agent, information on what brand of dog food you prefer. And if you think about it, that type of data really belongs outside of the core database in something that's built for that type of unstructured data, not in our core database. And that's the real driver behind these external data design patterns. Use the SaaS system for that primary data. Use the SaaS system that's optimized for operations like search and incident management, as opposed to what are really big data issues, big data warehouse issues. And if you look at some of the scales, 6 terabytes of data, well, if I can get 20% of that data out of the database, everything in the SaaS environment will perform better. And that's why we look at external data as a key thing in our architecture. And if you look, some customers are really good at it. So real briefly, just to show what Service Cloud looks like, Service Cloud is an application that's primarily, like I said, around solving problems. This is a particular customer that called in, Kirsten Schmidt. She's talking to an agent about her Wi-Fi card not working, but she entered this ticket through a web portal and later called in. And when she called in, the agent can very quickly see that she has no warranty on this particular laptop. And this is external data. None of this data lives inside a Service Cloud. All of our core data about her does, but not that secondary data about this particular laptop. Because how often does a customer call in with a particular warranty question? And this is a perfect example of secondary data. The other thing you can do with secondary data is integrate to systems of record. In this case, Kirsten's primary information isn't in Service Cloud because we don't use Service Cloud to ship packages to her. We use Siebel. So in this case, I'm showing how we can pull in the full contact history of this agent or this customer into the agent's desktop dynamically. Once again, live data, no reason to synchronize it. And until this person calls in, there's no real reason for this data to reside inside the Service Cloud database. But that doesn't mean it's a second-class citizen. I can click on this record, come into an editable mode, and through SOAP Web Services, edit this data in place. And this is core capability that's been in Service Cloud for many, many years. If you think about it, why integrate those systems so tightly? Why pull the data into Service Cloud just so someone can see it and action it? And this is what we're showing in this external data integration design pattern. If you look here, these are tables that are created in Service Cloud dynamically by an add-in that loads at runtime. And the power of that is an agent can come in here, not IT organization, but an agent can come in here and change what fields are surfaced. As you can see, this particular agent might work on HR issues, in that case needs a birth date. But maybe another agent doesn't. Well, all the administrator would have to do is come in here and drag this field out. Or maybe they need approval authority on it. Well, they can just drag it up here and drive it in. When they save this report goes into a workspace, and when you looked at that contact report you saw previously, it would change based on what an administrator did. No need to pull in IT, no need to talk about the other database, no problems in terms of accessing that data real time. And that's the real power. You know, a citizen developer, a very talented agent can go optimize their workflow and make their team more productive without engaging anyone. And this is the power that's currently being done through report add-ins in Service Cloud. So if you look at Service Cloud, it's currently designed point-to-point, and our accelerators are typically point-to-point. In this case, we're talking from our contact center agent application, which is a Windows desktop program, directly through SOA to the system of record. And if you think about it, if I wanted to then talk to like the ERP system, maybe it's SAP, I would have to have a developer go do that custom work and expose those SOAP web services to talk to this ERP system. Well, that doesn't make a lot of sense. What makes a lot more sense is to use something more like the connectivity tools in Progress or OData. So one of the questions I would ask is, why did you choose OData? And back to some of the things that Mike was saying, as the standard matures, it is a network effect. But if you look at what Service Cloud has under the covers, we have a Windows agent desktop that runs on a customer's computer. We also have a PHP open standards-based web portal for customers to create incidents. We have a CentOS backend. We have iPhone and Android mobile applications. We have a MySQL database, and we also have Java in the backend. That makes OData very compelling because there's already libraries that I could leverage in most of these platforms. And that makes the work that a customer or a consumer has to do to develop it significantly less than if I were to come up with something custom for each of our components of our platform. Anyway, this slide is basically to show that Service Cloud is a truly open source platform, and open standards like OData make a lot of sense. So then, if I wanted to then talk to like this ERP system, I can either write another accelerator that talks directly to the ERP system, or I can adopt something like OData through Progress or one of the other connectivity vendors out there. And I can talk with the same type of protocol against whatever database is implemented in the back end without really needing to worry about the specifics of it. And that's where OData really becomes powerful. I can connect through Progress or another middleware. That's not really fair. Connectivity vendor like Progress to a Salesforce or TripBin, or pick something out here in the ecosystem, and that's very, very powerful. If you look at an example of how we've done it in our open source Accelerator for reports, we specify an endpoint, we specify what entities we want to expand, and at runtime, the program actually goes and expands all the tables required and all the relationships into something I can drop into a report. That's very powerful. Those reports are then dropped into the agent desktop, and that allows a customer to then see in action and navigate between different data sources, that data without ever pulling it into Service Cloud. And that makes sure it's up to date because it's live from the system of record. It reduces complexity for the integration. And once again, an administrator can change what he wants to see. Maybe expected revenue isn't something this agent should see. And they can also then click on a report link like this and navigate through the entire model that was exposed through OData in a series of connected reports and actually edit the reports wherever they exist. And that's the accelerators for OData that we're building. I'm going really fast. Hopefully I have time for questions afterwards. Sumit, back to you.
Thank you. Roderick. It's fantastic overview on what you're working on with the OData at Oracle, and let's transition over into some questions here. And let me scroll through my list. All right, let me start with a question here. Maybe this might be good for Mike, but when looking at producing OData, is it recommended to support the 2.0, 4.0, or both for compatibility within the ecosystem?
That's a great question. One of the interesting things about OData is that we, as I said, started out as sort of an open process for defining OData, and we moved to standardized through OASIS and now coming through ISO, basically to make OData more open to certain enterprises and government agencies that were unwilling to implement a spec that was not a standard. So if you are interested in working with government data, or you're interested in working with enterprises, particularly outside of the U.S., then OData 4.0 becomes much more interesting to you. And so we do see a trend going towards OData 4.0. OData 4.0 also, we defined some new conventions that weren't part of previous versions of OData. And so really, if you're working on a new project, I'd encourage you to look at OData 4.0. That's where we're putting our efforts. That's where we're putting our resources. That said, not all the industry is yet to OData version 4. And so practically, you probably want to look at the clients or the services that you want to reach and what versions of OData they're currently supporting and what their plans are and time frame for moving to OData version 4. So if you're looking at something like Excel, Excel has support for reading data in from an OData version 2, 3, or 4. Something like Tableau currently only supports OData version 2. And hopefully they're working on their 4.0 plans, but I haven't heard any public announcement of what their plans are. So looking forward, a new service, think about OData version 4, look at the functionality that it provides, but also look at the clients and services that you're interested in interacting with, and talk to them about what their plans are for moving to OData version 4.
All right, great. Thanks, Mike. All right, next we have a lot of questions. This is great, so keep them coming. Next question is, looks like we can only read data in Salesforce from the external data source. So I can talk about that. So this Salesforce Connect, formerly Lightning Connect, initially when it released was read-only, but they've since introduced read-write support. So when we create those native objects, you can actually not only just read from the OData endpoint, but you can also write back to the OData source. So we have Salesforce Connect has read-write capabilities, and so does Oracle Service Cloud in their implementation. And I played with that with Roderick, and it worked great to read and write data from different OData sources. See the next question. This one is more for Roderick. Is Oracle Data Services compatible with OData?
Interesting question. I don't know what product they're referring to, and unfortunately, Oracle has thousands. Currently, we are working with Progress and other vendors as a producer of OData. There are plans, obviously when is something I don't know the answer to, when our integration cloud services will also be able to be have support for OData. That's out in the future, so I'm sure this whole community would be interested in those announcements. One other thing I wanted to mention, which I didn't get a chance to, Sumit, is just the scale of the Service Cloud REST APIs and SOAP APIs. So the team understands, or the people on the phone understands, how complex or big this is. Our services are REST APIs, which are only for integrations, outside data being pulled from Service Cloud or pushed into Service Cloud. We currently handle about 7 billion transactions a month. That just gives you guys an idea of the scale of what we're talking about and why a standard starts to become really important.
All right. Thanks, Roderick. Let's see. Next question. Actually, I can't even pronounce this word. Let me let's go ahead and scroll down a little bit, and maybe I'll Google it and see if I can pronounce it before I read it. But let's try this one. This one might be from Mike. Can you cite any OData use cases in the mobile space, iOS, Android, or other?
Can I cite any use cases? So Office 365 is a great example of a fairly large service that wanted to make its data more universally available, and so they aligned with OData as a REST API because it does reach iOS and Android and all of the other platforms. They build a library for iOS and Android that makes it more accessible on those, that kind of encapsulates some of the Office-specific semantics, but you don't need to use those libraries, so you can use them, you can consume them directly. The other thing that works really well for mobile is JavaScript, because almost any of those different platforms support JavaScript, and as I mentioned before, there is an Olingo library for JavaScript for consuming OData version 4 services.
All right, thank you. Here's another one. It looks like this one is, or there's a question, a general question around with the OData standard and the concepts you've represented. How is this? Where does this play into the Internet of Things with Windows 10? Maybe Mike, do you have that one?
Sure. So OData is very useful for services that have interesting information behind them. So the stuff that Redfish, for instance, is doing is a great example of a management API that has a lot of data behind it. So if you're thinking about managing a data center, the Redfish specification uses OData to describe the current state of your disk drives, of your computer systems, the chassis, and all the other components that make up your data system. And so you can query that system, but you can also interact with that system. So you can send commands like reset commands or format commands and so forth through OData-based REST API. So that starts to get into the Internet of Things, where you're talking about smaller and smaller devices that you're using OData to interact with. Now, Microsoft has had a few different directions that we've looked at for the Internet of Things. And at one point, we had something called the Internet Information Services, the IIS, ISS. Anyway, it was very OData centric. So it used OData to describe the devices that you're talking to get data from the devices that you're talking to, and to send data to the devices that you wanted to, for instance, turn lights on and off. So it was interesting to look at OData as a control API for those individual devices. But more interesting was when the data from those devices was aggregated and placed in the cloud, the ability to use OData to query the information about those devices. So if you have something like a thermostat, you could query, what were the temperatures and when did the heat come on, and all of that different information. So that aggregation of information together with information like what was the weather that day and what was my calendar, when was I home, when was I away, is all of particularly interesting use of OData. Now, as far as exactly how that integrates with Windows 10, another popular standard in the industry is the all-join technology that defines a common way for devices to speak to central hubs. And the all-join specification has a interoperability layer that allows other services to be able to plug into the all-join network. So I think it's very interesting to define a OData bridge into all-join so that if something like Redfish wants to plug into an all-join network, it can do so very easily, exposing its resources as OData. That can interact with the network hub, but then once the data from all-join is placed in the cloud, then you can query that information again with OData, and you can do some analysis on it, you can do machine learning, and so forth. So I don't know if that entirely answers your question. There's a limit to what I can say about the future strategy for Internet of Things, and specifically in Windows 10, but hopefully that gives you an idea of how these different technologies can relate together to pull data in from a variety of different sources and really make that data useful information.
All right, great. Thanks, Mike, for answering what you can there. And let's see, the next question would be for, let's say it's for Roderick. This one's a good one for you. When will the OData Accelerator for Oracle Service Cloud be available?
The Accelerator for Service Cloud is planned for the February release. Obviously, being in product management, I can't commit to times or dates, but that's when I would expect to look for it.
All right. So there are a couple more questions, but I think we're wrapped up out of time. We'll try to answer those that we didn't get to by email. And let me pause here since we'll wrap it up. Cindy?
Well, thank you so much, Sumit and Mike and Roderick. That was some excellent comments and some excellent information to share with our audience. I think this wraps up our webinar for today. Thank you again for joining us, and we look forward to having you on future Progress Data Direct webinars. Again, thank you and have a great rest of your day.